Hey students, we're going to go over oxidation reduction reactions in this video, or redox for short. So before we get into it, we're going to take a look at this simple single replacement reaction. So when we look at it, this first question asks, what is the charge on the zinc metal? Well, here's our zinc metal over here, and as you can see, it's a neutral atom. So the charge is going to be a 0 when it's by itself. Now, what's the charge on the copper in solution? Here's the copper in the solution. So its charge is going to be a +2. We know that from our ionic compounds unit. What's the charge of the zinc in solution? Here's the zinc in solution. And so its charge is going to be a +2. And then what's the charge of the copper metal? Again, here's our copper metal. And as we see, it's a neutral atom, so it's going to be 0. So it's asking us now which metal lost electrons. Well, we can see, let me change my color here. We can see that the zinc went from a charge of 0 to a charge of +2. It got more positive, so it had to have lost electrons. Whereas the copper went from a +2 to a 0, and electrons are negative, so in order to go down to a 0 charge, a neutral charge, the copper had to have gained electrons, okay? Now let's look at this single replacement reaction. So first question, what's the charge on the copper metal? Well, when it's by itself, what's its charge? 0. What's the charge on the silver in the solution? In the solution, the charge of the silver is a +1. What's the charge on the copper in the solution? Well, the copper in the solution is +2 over there on the product side, and the charge of the silver metal, here's our silver metal all by itself, is 0. So which metal lost electrons? Well, again, looking at their charges from the reactant side to the product side, the copper went from 0 to +2. It got more positive, so to get more positive, it had to lose some negativity, so the copper lost electrons. The silver went from +1 to 0, so the silver gained electrons because it got more negative, okay? So these were both examples of oxidation reduction reactions in which there was a transfer of electrons between those metals in those reactions. As we know from previous units, all of our metals lose electrons, and some metals have an easier time losing electrons than others because of that Coulombic attraction between the valence electrons and the nuclei. So when we look at something like this, which is an activity series, that can tell us how active a metal is and how likely it is to lose electrons as compared to another metal. Nonmetals are opposite because nonmetals like to gain electrons. And so when the attraction is stronger and the nonmetal has an easier time pulling electrons in because of its attraction, then it's going to have an easier time gaining electrons versus losing electrons. So an oxidation reduction reaction is when there is a transfer of electrons between the reactants involved in the reaction itself. So as you can see in this picture down here, we have what we called an electron donor. It's going to donate an electron, and then we have an electron acceptor that's going to accept an electron. So we see that this electron goes from whatever this blue atom is, and it goes over to the red atom on the product side. So this blue one lost an electron, which is why we say it went through oxidation. This red atom here gained an electron onto the product side, so we say it went through reduction, okay? So what are oxidation and reductions? Well, oxidation originally meant that something is going to combine with oxygen to form some kind of oxide. Now these are all supposed to be arrows. I don't know why it shows up like this. All these little boxes are supposed to be arrows. So a common example of an original oxidation definition is the formation of rust. When iron reacts with oxygen in the air and forms iron oxide, that would be called an oxidation reaction because it combined with oxygen. Well, now we know that it's not just involving oxygen, that there's other things that can classify as an oxidation reaction. And so our modern definition is that there is a loss of electrons, a loss of electrons. Reduction, let me put this arrow here. Reduction originally meant that a substance was going to lose some oxygen. So in the example here, you can see that the iron lost oxygen as it formed the product. Well, now we know that it's not just about the loss of oxygen, but it could also mean that there was a gain of electrons. So oxidation is a loss of electrons, reduction is a gain of electrons. Now, these have to happen at the same time. You cannot have one without the other. So if something is losing electrons, something else has to be gaining those electrons. You can't just get rid of electrons willy-nilly. So we have a couple of mnemonic devices that can help you learn what oxidation and reduction are and remember these. And one of these, whichever one you want to remember, but remembering either of these is going to help you guys. Oil rig, or Leo the lion says grr. Oil rig, oil is oxidation is losing, and remember it's all about the electrons. So oxidation is losing electrons. Rig, reduction is gaining electrons. And then the Leo the lion says grr. Leo means loss of electrons is oxidation. Gain of electrons is reduction. So commit one of those to memory. So we want to see if there's any oxidation reduction going on in these two reactions. So when you look at these, first off, you'll see these little numbers across the top of the reactions. Those are called oxidation numbers. We'll go over how to determine what those oxidation numbers are in the next video. Right now, these are here to just help us to determine whether or not oxidation reduction reactions are happening. So you want to look from the reactant side to the product side, compare the oxidation numbers for each substance as a reactant to its product to see if those oxidation numbers are changing. In that top reaction, barium is +2 on both sides. Chlorine is -1 on both sides. Sodium is +1 on both sides. Sulfur is +6 on both sides. Oxygen is -2 on both sides. So there is no oxidation reduction reactions happening in that top reaction because everything has its same oxidation number. But on the bottom example here, you can see that sodium and chlorine both have an oxidation number of 0 on the left side. And they have charges, because they form sodium chloride, they have charges on the product side. So there was a transfer of electrons. So there is oxidation reduction happening in the second example. This is another example. Now this one does not have oxidation numbers, but when we were talking about in those first couple of slides, when you see neutral atoms, like the sodium and the sulfur over here, they have no charge because they're neutral. So they're going from a neutral atom to something in a compound. So when you see something like this, that automatically tells you that yes, there is some kind of oxidation reduction happening here. Now, sodium is going from a 0 to a +1. So that means it's losing electrons because it's getting more positive. So we say that it's oxidized. The sodium is oxidized because it lost electrons. Whereas the sulfur is going from a neutral atom to a -2. So it's gaining electrons because it's getting more negative. So the sulfur was reduced. Okay? So we want to identify what's oxidized and what's reduced in each of these reactions here. Okay, now remember, oxidized means that it is losing electrons. So essentially, it's getting more positive. And we're trying to figure out what's reduced, which means that it is gaining electrons, getting more negative. Now in these examples, we've given you the oxidation numbers because we want to start getting you guys to practice identifying what's oxidized and what's reduced before you have to assign oxidation numbers yourself. So when you look at that first example here, which element, the sodium or the chlorine, is getting more positive? Well, the sodium is getting more positive, so the sodium is oxidized because it's going from 0 to +1. Chlorine then is reduced because it's getting more negative, it gained electrons and gained some negativity. In our next example, we've got a little bit more things going on. We've got copper, oxygen, and carbon. So we're trying to figure out which one is oxidized, so which one lost electrons. Well, we're looking to see which one got more positive. Well, it looks like the carbon is oxidized, and sorry, the numbers are slightly off here, but this goes with this. This one's +4, the oxygen is -2. So the carbon went from +2 on this side to +4 on that side. That's why we say that the carbon is oxidized. The copper then is reduced because the copper went from a +2 on the reactant side to a 0 on the product side. Now notice the oxygen did not change oxidation numbers, so we did not list the oxygen as being either oxidized or reduced. Looking at this last example here, sorry, everything on this product side got a little mixed up here. So let me write these down here. +2 -2, 0, +1 -2. So we have even more stuff to look at on this side. So we're trying to figure out which one is oxidized and which one is reduced. So which one, looking at all of these things here, which one is getting more positive, because that's the one that's losing electrons? Well, it looks like the nitrogen is losing electrons. It's getting more positive because it has a -1 charge over here on the reactant side, but it has a 0 over here on the product side. And then which one is getting more negative? Which one is gaining electrons? Well, the carbon goes from a +4 to a +2, so it got more negative, so the carbon is being reduced. Okay. So our next video is going to go over assigning oxidation numbers. So, whoopsie. So let me know if you have any questions about identifying oxidation reduction first.